All right, 7, 8, 9 are calculating the magnitude and direction of a vector, and just like most of trig, we're back to thinking about right angles and sine, cosine, and tangent, and all of those good things. So, magnitude of the vector is just how long is this vector. Well, if I draw my right triangle here, this side is -3, this side would be +6. So my vector that I have is -3, 6. We said to calculate the magnitude of our vector, we're using the Pythagorean theorem, and we said the magnitude of the vector was the square root of a squared plus b squared. And so we're going to take -3 squared plus 6 squared, which gives me 9 plus 36, which gives me the square root of 45. Instead of simplifying the square root of 45, up here in our directions, it says round your response to 2 decimal places. So we actually have to calculate what the square root of 45 is. So I'm going to grab my calculator here. Square root of 45 would give me 6.7082. I'm rounding to 2 decimal places, so 6.71 would be what the magnitude of my vector is. Now that's only part of the problem. They want us to find the magnitude and the direction of the vector. So what they really want us to do is figure out what this angle is in here. Because I don't want to use a rounded off value, I'm going to use these 2 sides that they already have labeled. I have the opposite and the adjacent, so I can say that the tangent is equal to the opposite over the adjacent. So I'm going to do the inverse tangent of, and I'm going to have 6 over -3, which would simplify into -2. Now we are going to do our angle in terms of degrees, so make sure your calculator is in degree mode. If you're not sure, mode, and hit number 1. Otherwise you should see that little D up there on the top of your screen. It's in degree mode. So I'm going to do shift tangent to get inverse tangent of -2. I get -63.4349. Now you can see this angle is not -63. -63 would be going backwards this way. So even though I get a negative answer, I'm going to put it in as a positive because I really measure my angle going this way. It's the same angle, just going in the other direction. And so for my answer, rounding off to 2 decimal places, I'm going to say that it's 63.43 degrees, and that would be how big theta is. So even if it does come out to be a negative, we're going to get the positive angle, 63.43. So number 8, again, I want to find the magnitude and the direction of my vector. This one here, along my x-axis, I would have 5. Along my y-axis, I also have 5. And so my vector would be 5, 5. The magnitude, I'm going to do the square root of a squared plus b squared. So 5 squared plus 5 squared. 25 plus 25 would give me the square root of 50. And again, we're going to do 2 decimal places, so we're going to use our calculator. What is the square root of 50? 7.0710. Rounding to 2 decimal places, 7.07 then is the magnitude of our vector. Finding our angle here, again we have the opposite over the adjacent, so the tangent or inverse tangent would be 5 over 5. So inverse tangent of 1 is what I want to do. So shift tangent of 1 gives me 45 degrees, and that is positive. This is 45 degrees here, and so that's going to be my answer. Number 9, same kind of thing. This would give me -3 in my x direction, -7 in my y direction. So my magnitude would be the square root of -3 squared plus -7 squared. So that would be 9 plus 49, which would give me the square root of 58. Again, I'm just going to use my calculator and do the square root of 58. So 7.6157 to 2 decimal places then. My magnitude would be 7.62 because I need to round that one up. For my angle here, again, I have the opposite and the adjacent, so the inverse tangent would be -7 over -3. So I'm going to do the inverse tangent of +7/3. So inverse tangent of, and I'm going to use parentheses because I'm not real sure on this calculator if I need them or not. So to be sure, I put parentheses around my fraction, and I get 66.8014. Again, that is a positive angle, so I'm okay there. So my answer is going to be 66.80 degrees for what the measure of that angle is.